Good afternoon and welcome to this session on Digital Twin with Molly and Sandeep from Atos. We are excited to hear how business can be transformed through the application of Digital Twin. This is one of the most important topics, being part of the Atos and Siemens joint investment, which is started in 2018. During this presentation, you may use the Q&A function to post any questions you have for us. We will take time to answer those at the end of the session. With that, Molly, please take over.
Good afternoon, good morning. Welcome to our Digital Twin offering presentation. My name is Murli Srinivas, and I'm the business owner for Digital Twin at Atos. Companies, businesses, and industries in general have been constantly rediscovering themselves to perform better and with increased profitability. As a matter of fact, basically, every industrial revolution actually has seen fresh push towards improving efficiency, performance, and throughput. This phenomena spans across the entire product lifecycle, as you see in the picture. Moreover, these years, the products have become smarter and have been more communicative, which means they have to be managed differently as compared to our traditional products through realizing of the closed loop product lifecycle management. Let us see what these typical business challenges are through the product lifecycle. Industries in general have been facing business challenges such as time to market, product individualization, and several cost pressures over these years. These have forced businesses to transform themselves to sell their products and services more efficiently. As a result of it, business have reinvented themselves, as you might have seen around you, by innovating and discovering new business models. The fourth industrial revolution has been a big push towards solving these business challenges and issues through Industry 4.0. Let us look at some very generic challenges which Industry 4.0 targets to address. So as you see here, lack of transparency, backward traceability, and missing feedback from field usage or factory inputs have been common root causes for most of the issues, which we have discovered during our discussions with large customers and middle tier customers and so on. By closing the backward loop, one can solve most of the business challenges. We use digital twin as an approach to close the product lifecycle loop, which helps compare the real physical world with the virtual digital twin. The objective of comparing these two worlds is to validate the design criteria and assumptions made during the design process against the real performance in the field or a factory. I think this is true for all your products, what you see, from cars to aeroplanes to even mobile phones, of how it is designed and how the performance happens. Such a comparison can be simulated by applying to a product performance or manufacturing effectiveness or even supply chain efficiencies. Let me give you a glimpse of when, what, and how we started our digital twin journey. Close to around 2.5 years ago, Atos and Siemens jointly committed to a multi-million euro investment into realizing a true digital twin, where both companies could benefit from bringing this to the market. True to our legacy, the core competence of Atos has been in the area of system integration and infrastructure topics, complemented by the state-of-the-art solutions from Siemens. We jointly started to address digital twin to be a leader in this space. To start with, products and processes are represented across multiple enterprises, as you see, whether it's PLM, ERP, supply chain, or even warehouse management. And in addition to that, we have been also doing a lot of business intelligence and analytics on top of these enterprise data. With the products becoming smarter and ever-dropping cost of communication, we find real-time sensor data to get insight into product behavior under external, very harsh external conditions. A 360-degree view of these digital data across the systems, which are contextually connected with each other, and the hidden knowledge of the enterprise basically helps bring all the product knowledge together, and that forms the backbone of what we call as a digital twin meta model. All this is being done with the sole objective of driving digital transformation and enabling our customers create new business models. So what exactly did we start to do during our digital twin journey with our customers across sub industries? We baselined some facts and identified key challenges which needed to be addressed. Number one, industries were looking at digital twin not as an hype topic, but they were looking at to solve real business challenges and achieve their business KPIs. As a second point, the business problem statements was very hard to describe. They had all the data in the world, but they did not know how to scope the solution and how they would like to use this data to actually achieve the business objective which they were looking for which we discovered together with the customer what is called as a digital twin 4M6C methodology, which you see on the left hand side of this slide. This is more a discovery workshop and an approach to actually scope the solution and also address the customer imperatives or customer influencers in solving that problem. Almost all businesses want to monetize existing application data, whether it is from ERP or PLM or so many other systems. And the data which they have historically collected over years and the best practices they have, they want to collectively use it. So no one wants to invest into their base information, base data building, base master data. So we bucketized it into three different buckets: enterprise data, field data, and semantic data. And all of them have different characteristics and different frequency and completely different way of collecting and monetizing that information. So we brought them in context of each other. And this is done using our digital twin platform, which actually brings these three digital threads together. Our digital twin platform is hosted can be hosted on any cloud platform and can actually integrate any of our customer applications. So just to give you an idea of what exactly what we mean about a platform, basically, this platform being as generic as it is and as open as it is in terms of architecture, it also is verticalized to incorporate specific IEC or even VDMA standards in terms of data sets, in terms of data collections, in terms of formats, and so on and so forth, as a very verticalized way of solving a business problem. Second point is basically these business applications are all offered as a software as a service to our end users with great customer experience, including making it available on mobile devices. Very intuitive 3D visualization, AI, machine learning, natural language processing, and cognitive knowledge applications. Our customers benefit a lot out of it and goes a long way in targeting the customer business KPIs. We also have integrated what is called as a very niche players or ecosystem partners who have very deep know-how in their specific domains and expertise to be part of our customer projects, which we call very proudly as citizen development, by providing them open APIs where they can actually participate in the joint development together with us. With this, it is time now to get a real feel and a value of what we have done together with customers, for which I would like to bring my colleague Sandeep, who will walk you through some of our customer examples, and you could enjoy a real feel of what digital twin and how digital twin can be applied into a customer scenario. Over to you, Sandeep.
Thanks, Murli. My name is Sandeep Ban, and I am Program Manager for Digital Twin. We started our digital twin journey with one of the leading independent service provider and one of the leading OEMs in renewable energy. As mentioned by Murli, our approach towards digital twin is to capture 360-degree view of asset by capturing field data, enterprise data, and semantic data. In the first demo, you will witness how we try to bring virtual and physical world together using power of physics simulation and AI in order to optimize design, which will in turn improve performance. The system learns from field data and helps designer to design future models in a better way. Enjoy the demo.
Wind turbines are complex assets working under harsh environmental conditions with extreme temperatures, humidity, and wind conditions. They are also complex from an engineering perspective. Standing 200 feet tall, complex systems from a wind turbine are designed to simulate real-world performance using assumptions and hypotheses. Digital twins help us close the loop by providing real-time environmental data to carry out engineering simulations. The airflow patterns can be analyzed to optimize future design for better throughput. Design for manufacturing and design for service can be achieved through systematic feedback from manufacturing and field services. The Atos Digital Twin solution captures feedback through semantics and field data. System breakdown of a wind turbine helps modularize the asset and drive reuse across different models. However, the simulation of individual systems across models needs to be performed upfront based on systematic field experiences. Machine learning models are compared with physics simulation models of an asset for performance, such as wind farm layout design through wake effect analysis.
Moving on from product development to manufacturing, we show you how we use digital twin to increase operational equipment efficiency, which we call it as OEE, reduce inventory, and increase throughput. Sometimes focusing on only OEE of CNC machines or any equipment could not be beneficial, but identifying bottlenecks in entire process could improve overall efficiency of plant. Using 4M6C methodology, in addition to optimizing machine efficiency, we also managed to eliminate those bottlenecks within the shop floor, thereby increasing the throughput and reducing piling work in progress inventory. This goes a long way in realizing smart factories. Let's look at such an implementation at leading aerospace Tier 2 manufacturer.
Complex products such as wind turbines require sophisticated manufacturing processes. Customer challenges such as production throughput and operational efficiencies require constant improvement. Critical assemblies are manufactured with a high degree of precision and tolerances to deliver the expected performance. High-quality, multi-axis CNC machines, fixtures, tool holders, and spindles are critical for producing complex products. Atos' digital twin solution for shop floor provides a 360-degree view of assets and processes, providing a shop floor dashboard to track plant OEE, production throughput, and machine utilization. Bringing together IT and OT data enables the realization of Industry 4.0, or Smart Factory. The application provides real-time status of the shop floor asset, along with failure events and service information. The predictive maintenance application provides intuitive analytics on the health of a spindle by predicting its remaining useful life. Additional analytics provide optimum parameters such as spindle speed, feed rate, and material removal rate against cycle time.
Business model are changing from product-based to service-based revenue models. Transparency and proactiveness is need of an hour. Let's see how field engineers and the operational managers are benefited through digital twin by using the power of predictive analysis for critical components and ontology capable of acquiring information in form of sound, video, image. We can predict failures well in advance. Not only we are able to provide information to field engineer, but we provide detailed analysis of problem such as what, why, where, followed by how to solve it. Self-learning is mantra of our digital twin platform, which uses sound bites, image detection, and videos for capturing knowledge and enhancing better user experience. Here our focus was to improve business KPIs, including availability of assets and reducing the cost of operation. Enjoy the demo.
How can I increase my yield? How can I reduce my cost of operations? How can I optimize the use of resources? Can I predict failures before it happens? Can I have a lean inventory? How can I have a fast turnaround time?
The Asset Overview and Performance app provides a 360-degree overview of all the assets installed across farms by contextualizing data from field events with the corresponding enterprise systems, such as PLM, SAP, or Service Lifecycle Management. The Service Manager uses the Performance app to visualize the asset location, along with real-time tracking and analysis of business KPIs, including mean time to repair and failure, and asset availability. The 3D visualization app provides a realistic view of field assets, including critical hotspots. This visualization provides field engineers an intuitive user experience to identify and analyze potential issues prior to service actions. This drastically reduces the mean time to repair. The Cognitive Assistant helps less experienced service engineers get insight into problems based on the company's knowledge base. Field engineers are also able to relate to similar occurrences in the past through the Cognitive Engine, which uses machine learning for image, video, and voice inputs. The remaining useful life of critical wind turbine systems can be forecasted using the Predictive Maintenance app. Root cause analysis of failures can also be monitors his farm improve the design and manufacturing the health of assets across fields. Critical faults trigger alarms. The key is to upkeep energy production using the predicted power versus wind speed, S-curve mapping it against the actual daily yield. A remote locking mechanism is also provided to authorized personnel for special cases or emergencies. Operations and inventory costs are key to a service provider's profitability. The report provides the opportunity to compare site-based cost analyses across asset makes, models, and locations. Field service engineers have the challenging task of performing their job under difficult conditions on top of the turbine, where they have little access to service information such as repair procedures, documentation, and spare part availability status while performing critical maintenance activities. The Maintenance Friend mobile application comes in handy, providing all online and offline information about specific assets and problem solving. The field engineer is also equipped with voice-based interaction with the application using natural language processing, to an extent that it is possible to find out availability of spares at his warehouse by clicking a picture of the damaged part. Using image-based pattern recognition and machine learning models, several other services can be provided. If the field engineer discovers a new, more efficient process to solve a problem, the company knowledge base can be enhanced through the mobile application. The mobile app also provides cognitive assistance, which leverages the company's extensive expert knowledge base. The engineers are able to interact through voice-activated inputs with a chatbot.
Our approach to your digital transformation is top-down, business-driven, flexible, and based on design thinking, which we call it as 4M6C methodology, where 4M is man, machine, material, and methods, in which we capture the influencers which are benchmarked for improvement. 6C defines the maturity of digital twin and automation leading to self-optimizing system. Proof of business value is best explained by feedback from our customers. Renom, a leading independent service provider, has rolled out digital twin solution across 25 wind farms with 500 plus turbines from 5 different OEMs and brands. Please hear from Vice President and CEO at Renom, Mr. Satish Jairaj.
We all agree that renewable energy is the way forward to drive decarbonization and move towards green energy. Service teams need to engage in challenging maneuvers to service these assets, climbing 200 to 300 feet several times a day. Maintaining offshore wind turbines adds further challenges due to logistical and environmental uncertainties. Predicting energy yield as accurately as possible to avoid defaulting on commitments is the goal of the Yield Prediction app, which uses artificial intelligence and machine learning. Let's hear from Mr. Satish, COO at Renom, about his experience.
Digital Twin from Atos is another platform where we could build a digital replica of your physical assets. We could integrate multiple systems into one platform for tracking asset performance from a 360-degree perspective. We could bring in SAP, RESCA, AMS, PLM all in one single window. Predicting the remaining useful life of components, yield prediction. We could also reduce unscheduled downtime due to component failures by predicting components that are at risk. To quantify a few of them, 20% improvement in MVT and TTR, 12% reduction in operational expenses on fuel. We could even reduce the loss in gap of data, which is down to about 4% compared to a 61% earlier. There was also a very small 0.2% increase in asset performance. Though this value is too small at the moment, we certainly know that this would be on the rise sooner. Digital Twin has further encouraged us to rethink on our current business model from a time-based model to an energy generation-based model. With continued support from Atos, we are confident that we could continue to scale new heights and achieve our goal to be the most preferred ISP for asset owners in the Indian market.
For further information, you will find all the links, and I think there will be all the leaflets and all these will be shared with you. For any questions, please feel free to ask questions.
You can also find a lot of links on our YouTube channel and also on the homepage or the homepage of Digital Twin at Atos. So all the links which are provided here obviously are also published in public domain.
Excellent. So thanks Murli and Sandeep for this interesting presentation and all the insights shared. We received a couple of questions that we tried to answer quickly. Please don't be shy to ask more. We will come back to all of them then in the next hours. So maybe the first one going to you, Murli. You stressed the methodology. Can you elaborate quickly what the difference to a product there How do we tackle here, and why is that important for our customers?
So I think the most important thing why have we had to come up with such a methodology was, as I mentioned, it is very difficult for customers, in spite of the whole digitization push, to scope what needs to be done so that there could be a business benefit in a very short term. So what we do is we do a discovery workshop together with the customer, using what Sandeep described as 4M 6C methodology, and that becomes a big differentiator in identifying what digital threads from the customer are relevant to be captured and mapped as part of the digital twin model.
Thank you. Okay, so that's clear. Can you give any rough figure? How quickly can a customer then expect some first results?
So I think what we do that very agile, and it's a very design thinking methodology. So what we try to achieve is, in a 2-day workshop, we baseline all the values which the customer would like to validate, and we preferably wish to engage on what is called as a proof of value, because we are not doing a proof of concept or proof of technology. It would be a proof of value, which should last not more than 3 to 4 months, depending on the complexity. So we size it in such a way that we are able to show some tendential improvement in those KPIs in a 3 to 4 month period, and
Just
then
to
go
add,
on and pilot.
right. Just to add here, we have now a lot of reusables, because when we this digital twin platform has created reusable assets for the industry. For example, renewable energy industry. If there is any customer for renewable energy industry, I think it will take us 3 to 4 weeks. It's a lift and shift because we are mostly connected to most of the most of the OEMs. So we call it as Gamesa, Enercon, or any OEMs in the market. So our platform is able to connect to all these OEMs. So it will be lift and shift, probably a couple of 2 to 3 weeks time.
Okay, excellent, clear. Quick answer question coming in. Did you already apply the digital concept in the healthcare industry?
Yes, we have done that with 2 of our customers. I mean, one more the pharmaceutical manufacturer, and the other one is the equipment manufacturer. We have achieved successes as far as the complex processes in the pharmaceutical industry is concerned. With the equipment manufacturer, we are in the process of defining and scoping the benefits which the customer can get.
Excellent. And then final question, just quick confirmation, the solution can be applied for design, production, and the product twin. Is that correct?
Correct. Yes. Correct. It can be applied to any of the processes or business domains across the entire product life cycle, whether it's from R&D to production planning to prototype building, production shop floor, and to services, and even after sales and retrofitting.
Excellent. Very good. So with that, our session is almost over. So thank you all for being on this live session today, which demonstrated how Atos is able to address business challenges and KPIs through our digital twin offering. The recording will remain live for you to look back at your convenience. Have a nice day.
Thank you.
Thank you. Bye-bye. Have a good day. Bye-bye.
Thanks. Bye.